So the second type of attack we're going to talk about is a situation where the attacker is sitting on the network. Okay, so what this means is that the attacker can, if this is the user's browser, right? So user talks to the browser, and here is the server, right? So the attacker can sit in the middle, right? And the attacker can intercept the traffic, right? And of course, sometimes the attacker can, sit in the middle and serve as somebody who forwards the data from between the browser and the attacker, and then the attacker and the server. Or alternatively, the attacker can just snoop on some of the data and allow some of it to go directly to the server, or a combination of these. So let's look at what are the types of attacks that are possible. So if the connection is unencrypted, right? So if it's a normal plain HTTP, then the attacker can intercept the data from the browser to the server, and they can also intercept all of the data from the server to the browser. So essentially, they can manipulate this communication between the browser and the server in any which way they want. So with unencrypted communication, the attacker can pretty much do anything on the network. So that's not a very interesting situation, because in most cases in real world, any server with anything even moderately important ends up using SSL. And so what we are really interested in is the attacks that become possible when SSL is being used. And there is a type of attack called SSL stripping that's very powerful, and is basically used to, as the name suggests, to strip out SSL. So even though the server and the client are trying to use SSL, the attacker somehow prevents them from using SSL and causes them to revert back to unencrypted connection. Okay, so why does this even happen? There is some history, right? So history is that historically, a lot of web pages were just HTTP, and there was no HTTPS. So clients may end up going to the HTTP site, even though there may be a HTTPS site. And typically, once the server is offering HTTPS, what the server will do is that if they get a HTTP request, they will simply redirect the essentially respond to the client saying, connect to the HTTPS server, right? So that's called a redirect. Okay, so that's what happens. So because of the redirect, normally, even if you type HTTP colon, say www.paypal.com, because of the redirect, you will go to a secure site, and you can see that over here, this green bar, the exact nature of this particular indication changes from browser to browser, but it's something that says, that it is a trusted site, and that its public key certificate has been verified. But if there is an attacker sitting in the middle, then the attacker can essentially drop the redirect request. And what the attacker can do is the attacker can do a man-in-the-middle attack, where the attacker is talking to the user, to the browser, and this communication takes place over HTTP. Okay, so the user therefore continues to see, okay, this is a normal HTTP connection. They don't know that they are talking to the attacker, because the attacker controls the network. So even though they think they are talking to www.paypal.com, the data is going to the attacker, but the user doesn't know that. Then the attacker has a HTTPS connection with PayPal, And what they are doing is that they are sending any request from the user is being forwarded to PayPal, and the PayPal response is being again forwarded back to the user, right? So basically the attacker is sitting in the middle and they can see everything. And when the time is right, they can modify the pages and submit requests on their own if they choose to. Okay, so again, this is why when the attacker is present, the connection seems to go through, and you still get a HTTP connection to PayPal. Okay, so the same thing can happen even if, let's say, the website uses a combination of HTTP and HTTPS. And let's say there is a form, say a login form that is sent over HTTP, okay, because somehow the website vendor thought, okay, there's nothing sensitive in the form that I'm sending to collect the password information. And so I will use HTTP. But then what can happen is that the attacker can intercept this form page, and they can sit in the middle like this, and they can look at the form, and then they can say, hey, when the form is submitted, it's going to be HTTPS. You can imagine that was what the server intended, because now there is password information that's going to be sent when the form is submitted. So the server wants that to be encrypted. But what the attacker can do at this point is, when the form comes in, what they send to the victim is they take out the S out of here. So what the victim sees is a form that just has HTTP. And therefore, when the user types, submits a password, then that information is in plain text, and the attacker can intercept that. And then, of course, the attacker can forward that information through a secure connection to the web server. And so they can essentially sit in the middle and monitor all of the traffic while stripping away the use of HTTPS. So how can this be prevented? So there are a range of things that the website provider needs to do. So one of the things to do is to do full site SSL. So make sure that there are in some pages that are in plain HTTP, because once something is in plain HTTP, the attacker can start playing around with that, and therefore they are able to do this SSL stripping. In addition, to protect the cookies and so on, the secure cookie option should be set, which will cause the browser to send out the cookie only if the channel is encrypted, right? So only if you use HTTPS, it'll send out that cookie. Otherwise, the cookie won't be sent. So this means that even if the attacker is doing a man in the middle, as in the this scenario, because this is just HTTP, so a secure cookie won't be sent over here, right? So only if there is an end-to-end encryption, secure cookies will be sent. So that's one measure that can be taken. The second measure is called the HSTS, which stands for strict transport security, right? HTTP strict transport security. And what this does is it forces the browser to always contact the server over encrypted channel, right? So even if the user typed in HTTP colon something, let me get back to where I was. Yeah, okay, so back here. So even if the user typed in HTTP, because the HSTS protocol is in effect, So the browser will automatically convert it into a HTTPS request. Okay, so that way, even if the attacker tries this SSL stripping, it won't work because the browser will just automatically go to HTTPS site, even if it says HTTP. Okay, so that's the second thing that can be done. But the problem with this approach is that the first time the user may still contact the website using HTTP. And when this contact is done, that's when the server sends a message saying, okay, use the strict protocol. So from then on, the browser will use only HTTPS. But what if the attacker intercepts the very first message, and so this HTTPS message is never received? So in order to deal with that, a technique called preloaded HTTPS was developed. And in this case, the websites ask the browsers to mark them as HTTPS, okay, even before the user ever contacted them, right? So in the browser's code, when the browser, these sites are pre-marked as using HTTPS. So there is no sort of possibility that an attacker that there could even be a first message that is sent over normal HTTP. So, and you might wonder, why are we worrying so much about a network attacker? Because that seems like a unlikely scenario. But you have to think about several scenarios where this can in fact be a problem, right? So one of them is, let's say you are in a in a business organization, and your business organization can monitor all of its employees, and so they definitely have the control over the network, so they can try to monitor your HTTPS traffic by using the techniques that are described here. So if a browser vendor wants to really protect the end user security, then they will develop HTTPS and preloaded HTTPS and so on in order to prevent such attacks. The same thing applies if you, let's say, if you use a public Wi-Fi network, then the Wi-Fi network provider is in full control of the network, and they can carry out these attacks. And once again, HTTPS and preloaded HTTPS can help with that. And finally, if you think about authoritarian governments, once again, they have the network under their control, and again, once again, having this preloaded HTTPS can help deal with this class of attacks. Okay, so that's pretty much the only class of network attacks that I wanted to talk about. And now we'll move on to talk about client-side attacks.